Imagine looking down at a vast underground city. Thousands of tiny bodies are resting perfectly still. Then, in the blink of an eye, the entire population springs to life, surging forward in perfect, instantaneous unison. When we see that kind of flawless coordination, our human instincts tell us someone must be in charge. We assume there is a general barking orders, or a queen acting as a centralized brain to direct the traffic. But there isn't. No one is giving orders. Any everyday ant taking a single step can serve as the spark that wakes everyone up. Human systems rely on top-down communication, which breaks if the leader goes silent. But this network is resilient because the wake-up call can come from any corner of the nest at any time. Coordinating millions of individuals without a commander isn't a matter of high intelligence. It is a result of pure physical mechanics. To understand how this works, we have to look at the colony when it's quiet. At first, the few ants that are awake wander randomly. They move entirely on their own, unaware of the larger group around them. The shift happens at a mathematical tipping point. In this diagram, simple dots move randomly in a large space. But if the population crowds, speed increases, or interaction range expands, encounters become unavoidable. This triggers a sudden cascading shift across the whole group. This synchronization is an inevitable result of the numbers. Just like water reaching a specific temperature and suddenly turning into ice, the ants are pulled into a wave by the laws of physics. For that avalanche to actually take off, the colony relies on a hidden resource. Deep inside the nest, there is a massive reserve of resting workers waiting entirely motionless in the dark. They are woken up through a physical chain reaction. There are no sounds or visual cues involved. It's just a direct interaction between bodies. When an active ant rushes through, it rams directly into a sleeping neighbor. That literal shock instantly jolts the resting ant into motion. The moment that newly awakened ant flinches, it becomes a new activator. It immediately rushes off deeper into the colony to repeat the process. The math of the reaction takes over. One bumped ant creates 2 activators. Those 2 bump into 4, then 16, and the shockwave sweeps the room in a matter of seconds. By relying on direct physical impact, the colony bypasses the need for slow, deliberate communication. The colony essentially turns the bodies of its workers into a high-speed network, transmitting the wake-up signal across the nest at the speed of touch. But if it all starts with one random ant, what happens if that first ant gets tired and stops moving before the wave can reach the edges of the nest? The system survives because of a timing gap. This diagram compares 2 speeds. Left, a slow countdown represents the biological clock. Ants take time to tire. Right, a lightning-fast dot network shows physical transmission. A split-second bump passes movement forward. Because the shockwave travels so much faster than an individual ant's biological need to rest, the signal finishes crossing the entire nest before the first ants even have a chance to slow down. If this chain reaction is so aggressive, why doesn't the energy bounce around the nest forever and exhaust the entire population? The colony uses a third state to stop the wave, a mandatory rest period. After an intense period of activity, an ant enters a state where it is immune to collisions. No matter how many times it gets bumped by its neighbors, it simply cannot be woken up yet. These resting ants act as physical fire breaks. They absorb the energy of the bumps, breaking the chain of movement and stopping the domino effect in its tracks. This forced immunity gives the colony a necessary period of quiet. It resets the system so that everyone is recovered and ready for the next wave. By building a mechanism to stop the wave, the colony prevents itself from burning out. The ability to return to rest is just as vital to the group's survival as the movement itself.